Hello, great souls. Welcome back once again to this session. Thank you very much for joining me once again today. And we're going to be continuing with analytical geometry, focusing on the newly added knowledge on your grade 12, which is a cycle equation. Okay. All right. Before we go into finding the equation of a cycle, let's start by revising some of the key basics that we also learned in Euclidean geometry. Okay, but keep in mind that we are doing analytical geometry, although there's some interlink between this topic and Euclidean geometry. All right, so we know that a circle is made up of a set of points that are equidistant from the what? From the center. What does it mean? It means that the distance from the center to each point on your circle or circumference is always equidistant. As we know that the radius, those are the radius, right? That are always the same, right? Okay, so that's a circle. If you just have points that are equidistant from the center, we call that thing a what? A circle. And we know that a circumference is the distance around the whole what? Is the distance around the whole circle. So it's the circumference that is the distance around the whole circle. And we know that the distance from the center to any point on the circumference of the circle is called what? It's called the radius, right? And we know that all radius are equal. So we know that this is a distance from the center to the what? To the circumference. So how can we get that distance? If we have a point here, let's say AB, and we have another point here, maybe XY, then to get our radius, we can, that length of the radius, we can use distance formula, right? To say x at A minus x at, let's just say A minus x squared plus what? Plus B minus y squared. And we can use that distance formula to get what? To get the radius, the length of the radius, or rather the distance from the center to the circumference. Okay. All right. We can now move to the equation of a circle, right? Equation of a circle, right? So you've been learning in your function, equation of a straight line, right? We know that the standard form is y equals to mx plus c. We know the equation of a parabola. We know the equation is y equals to a into x minus x1 into x minus x2. It can be represented differently. A hyperbola, exponential, y equals to a exponent x plus q and all that, right? But in analytical geometry or coordinate geometry now, you now have to learn about the equation of a circle, right? And very, very simple. This is the standard form. It says x into open brackets x minus a squared plus y minus b squared is equals to r squared, right? We know that r is representing the what? The distance of the radius, right? Or rather the length of the radius. That is the length from the center to the circumference of the circle, right? It's the length of the circle's radius. That is our r. So a and b, now your a and b forms the coordinate of the center of the circle, right? You know that every circle has a center. So on your center, a and b, those are the coordinate of the center, where a stands for the x coordinate of the circle center and b stands for the what? For the y coordinate of the circle center. And that makes the standard form for an equation of a what? Of a circle. Okay, so we must also understand something very, very important. Your circle can have its center on the origin, right? And I will further elaborate on that as we move in this section or in this lesson. Or your circle can have your center not at the origin, right? So there will be slight difference, but this is the standard form, right? So if a and b, if our circle have a center at the origin, it means that our center will be 0 and what? And 0, because it is at the origin there, right? It is at the origin. Let me draw it properly. If it's at the origin, like we are saying, the center will be 0 and 0, meaning our equation will now change to say x squared plus y squared is equals to r squared, and this will form part of an equation of a circle with the center at the what? At the origin. And why is this the case? It's because if it's at the origin, our a and b are zeros, right? So if you go and substitute 0 on your original equation, where there is a and b, you put 0 here, a 0, b 0, it will end up being x squared plus y squared is equals to what? Is equals to r squared, and that will be a standard form for an equation that has a circle at the center at the origin. Okay, very, very important. If the equation of a circle is not given, this is a very important statement, right? If the equation of a circle is not given in standard form, right, you have to complete the square now for you to take it back to this standard form, because from this standard form we can already deduce what's our center here, right? So if you have this is a standard form for equation of a circle, so we know that the center will be what? It will be a and b, right? In other words, you change the sign there, and for you to get the coordinate of the what? Of the center. So if now it's not given in this standard form, maybe they give you something like x squared plus y squared plus 2x minus 3y is equals to 9, something like this. All right, it's still the equation of a circle, but it is not in this standard form. What you do is you complete the square. After completing the square, you complete the square for the x, for the values of x, also for the values of y. After completing the square, you can take it back to that standard form, and you can actually find what? Your centers again. Okay, let's just quickly go and look at those kind of different types of circles. All right. Okay, let's quickly start with the circle that has a center at the origin, although I've already shown you previously just now with that example. But let's just emphasize on this. If you have a circle with the center at the origin, and we know that the center will be what? The coordinate of the center will be 0 and 0. Then from the standard form, it says x minus a squared plus y minus b squared is equals to r squared. So from this standard form, you must get your a and b, and we know that our a and b is what? Is actually the center there, right? Is the origin, which is 0 and 0. And you're just gonna replace where there is a with 0 plus where there is b with 0, because those are our centers. Then you're gonna go and calculate the radius, right? So the radius, let me just put our center here, 0 and 0, and this line, you'll have a certain point on your circumference, x and y. So we need also to get the distance or from the center to the circumference, which is the radius, using the formula. Radius is equals to the root of what? X at origin is 0 minus x at p is x, but you'll have certain value there. So this is quite a fast example. And y at origin is 0 minus y at the is squared. So after using that formula, you're gonna have your what? You're gonna have your distance. Then you can go and replace. Let's just assume maybe you get your answer as 9, depending on your point P there, right? Meaning that where there is R, we're gonna put what? 9. But don't forget, it's R squared, right? According to the standard form here, it's R squared. So it's gonna be 9 squared, which is gonna be 81 actually, 81. So it's gonna be 81. So it's gonna be, if we simplify, x squared plus y squared is equals to what? 81. And that will be our equation of a circle with the center at the origin, depending on what is your point P there, right? What is your point P, and that will affect your radius. Okay. All right, let's just quickly look at this example here. They said find the equation of a circle with the center with center 0 with the point 5,2 on its circumference. So they told you that the center is 0, right? Sometimes they will tell you that with the center at what? At the origin, right? With the center at the origin, we have to find the equation of the circle. What is the standard form for an equation of a circle? Is x minus a squared plus y minus b squared is equals to r squared, right? From this equation, we must know our center, which is a and b, right? Our a and b is our center. Because it's at the origin, it's going to be 0 and 0. We must also know our radius. So radius is the distance from the center to the circumference. So you have your center as 0 and 0, and you are going to the circumference, and you have point P, which is 5 and 2, right? I can say x at the center, which is 0, minus x at point P, which is 5. So it's going to be 0 minus 5 squared plus, or let me put it there, plus, because of space, y at center is 0 minus y at the circumference is 2 squared. So our r is going to be the root of 5 squared is 25 plus 2 squared is 4. R is going to be the root of 29, if I'm not mistaken. Yeah, the root of 29. And that is our radius, right? After getting your center and your radius, that's all you need for you to be able to determine the equation of a circle. So you go and replace. Your center is 0, so it's gonna be 0 squared plus y minus our center is 0, a and b is 0. Our radius is root of 29, then we square. We can simplify this to finally get our equation. Is gonna be x squared plus y squared is equals to root of 29, which is 29, and this will be the equation of this circle. Okay, let's now move to circles that are not centered at the origin. Okay, these are circles with their centers not at the origin, such as this example given here. And let's see how it goes. So you can see this is a circle, right? And it has center M, it's A and B, and it has a point on the circumference, which is X and Y. Okay, so that is a circle that is not centered at the origin. So they can ask you 2 questions, mostly for you to get the equation of that circle, or rather they can give you the equation of those circles with centers not at the origin, and they want you to determine their centers and their radius. Okay, so we're just gonna start with this quick example. They said determine the coordinate of the center and the length of the radius of each of the following circle. We're gonna start with A. Very simple. Let's go and determine the centers and the radius. Okay, we must recall the standard formula for a circle. It says x minus a squared plus y minus b squared is equals to what? R squared, right? From this, we know that a and b are our what? Our centers. So if they're negative, you change their sign, they become positive. Okay, so, and we know that the answer after the equal sign is the radius squared. Then we can go and solve for the radius. Okay, so let's look at our a. We are given x minus 4 squared plus y plus 3 squared is equals to 18. Then we can deduce that, oh, our center is 4 and what? Negative 3. So you just change their signs there. Okay, so radius, we know that 18 is a radius squared, right? According to the standard form. So you say radius squared is equals to 18, then your radius will be the root of what? Root of 18. So radius is always positive because it's a distance from center to circumference. This will give us 3 root 2 units. Okay, so you have determined the coordinate of the centers and also the radius using that equation that they gave you. Okay, let's quickly move to B now. Okay, so with B, you are given this equation, very, very interesting exam kind of question. They like putting this question on the exam. They give you x squared plus y squared minus 6x plus 5y minus 4 is equals to 0. And you'll notice that this equation is very different from A, right? Because in A you could just determine the centers by just looking, right? But here it's quite different, right? So what you have to do is you have to first complete the square. You take it back to this standard form. After you have done that, you can now go and determine the centers and the radius, right? So you have to recall something that you learned in grade 9. Oh no, in grade 11, sorry, about completing the square. Okay, so let's just do that quickly. I'll first group this according to like terms. So it will be x squared minus 6x plus y squared plus 5y minus 4 is equals to 0. Actually, I can take 4 to the other side. Then it will be equals to 4, right? So when you complete the square, you go to the coefficient of x, right? So for coefficient of x, you just do it on a separate piece of paper. The coefficient of x is what? Is minus 6. And you also go to the coefficient of y here because you have to complete the square 2 times, right? You can just do it same time. The coefficient of y is what? Is a 5. That is the number that is behind y, or rather that is multiplying y. That's what we call the coefficient. What you do is you're gonna complete the square. You're just gonna take minus 6. Let me delete for y. Minus 6, and you multiply by 1 over 2 and you square it, right? So before getting the answer, you just say minus 6 times 1 over 2. It's minus 3 squared, right? You leave it as it is. Let's go to the coefficient of y. It is 5. So I'm going to say 5 times 1 over 2 squared. So this will be 5 over 2 squared, right? So what we're going to do is we're just going to add those values in our equation on both sides of the equation, right? So we're going to say x squared minus 6x. For x, we got it as minus 3 squared. We add it there, right? Let's go to y squared plus 5y. We add what we got. It was 5 over 2 squared is equals to what? 4. Very, very important. Don't forget. A lot of students tend to forget, right? They just add this side and that's it. And it's wrong, right? Mathematically, it will be wrong. What you do on the left-hand side must also be done also on the what? On the right-hand side, meaning that whatever you added on your left-hand side, you must also go on your right-hand side and what? And add. And that's very, very important. So the last step is very simple, and you'll find this question having 6 or 5 or 4 marks, right? It's a lot of marks really. So what you now do is you can now go and factorize. We're just gonna factorize this part. So it's also very simple to factorize. You just say x, you take that number inside the brackets. That's why I don't want you to get the answer of this because sometimes it can be hard for you to factorize. So it's very easy for you if you just take the coefficient to multiply by 1 over 2 and you square it without finally getting the answer of that square, right? Because you can now come and factorize easily. You just say x minus 3, you square. That's how you factorize that. If you expand it, it will give you the same thing. Okay, let's now move. We do it also on the y part. We're gonna factorize. So it's gonna be y plus what? 5 over 2 what? Squared. So it's very simple if you do it that way. Then it will be equated to, we have 4 plus minus 3 squared plus 5 over 2 squared. You can just use your calculator to get the answer of that. It's giving us 77 over 4. Can you see now? We have now converted our equation into this standard form, which is x minus a squared plus y minus b squared is equals to what? R squared. We have converted it into that form. Very, very interesting. We can now go and determine the coordinate of the center and the what? And also the radius, the length of the radius. It's now fairly very simple. So what is our center? Our center is gonna be 3. Remember we said you change the sign and what? And minus 5 over 2. Right. So what is our radius? Our r squared is 77 over 4. Then our r will be the root of what? The root of 77 over 4. Okay, so when you take the root of 77 over 4, it's just going to give you something like 4,39, which is actually root of 77 over 2. Right, you can leave it like that. Units. Okay, so very interesting. It's an exam kind of question. As I said, you just complete the square and you follow this procedure that you also learned in your grade 11. Okay, let's now move. All right, let's also look at this interesting question. They can want you to determine the equation of a circle, right? By just giving you maybe the coordinate of the center and 1 point on your circumference, something like that. And we already showed you with the one with the center at the origin, because we know the center will be 0 and 0. But what if the center is not at the origin, like this example? They said determine the equation of a circle with the center M. It's -1 and 3 to show that it's not at the origin, right? And A, which is a point on your circle or on your circumference. Okay, so they want you to determine the equation of that circle. We must recall the standard formula. It says x minus a squared plus y minus b squared is equals to what? R squared. So to determine the equation of a circle with the center not at the origin, you just use this standard form, even if you have a circle with the center at the origin. But the one with the center at the origin, you can just use the one x squared plus y squared is equals to r squared, and you just go and calculate your r, because we already know the origin is 0 and 0, so it will take us here. But this is quite different because we have the centers. Very simple. We just go and substitute. We know that -1 form part of our a, right? So if it's negative, we just take it as what? As positive. So it will be x plus 1 squared plus y minus our 3 is positive. It's going to be what? It's going to be negative. So squared is equals to r squared, which is our radius. Remember, the radius is the distance from the center, and we know that our center is m, -1 and 3. And the circumference, we know that there's something like a circumference there, and we have point A, which is -4 and -1. So we can go and calculate our radius using distance formula. R is equals to the root of x at m, which is -1 minus into, be very careful, the minus is of the formula, but our A is -4 also. So we square that distance formula. Y at m is 3 minus into y at a, which is -1. So be very careful with the negative there, because a lot of learners tend to make mistake. So it's going to be -1 plus 4 squared plus 3 plus 1 squared. So you can just simply use your calculator. So it's 3 squared, which is 9, right? Because it's -1 plus 4, which is 3, right? And when we scale, that is 9 plus 3 plus 1 is 4. 4 squared is 16. Then 9 plus 16 is going to give us 25. Root of 25, our r will be equals to what? Will be equals to 5. Okay, so we've calculated our r is 5. We can go and replace our r by 5 there, and we finally get that equation. Okay, so I'm just going to replace r by 5, and we can finally deduce our equation. So 5 squared, so it's going to be 5 squared, and we know that 5 squared is what? Is 25. That will be our equation of that circle. Okay, so it's fairly quite easy. You have your circle at the origin, and you have your circle not at the origin, but the standard formula works for both those cases. Okay. All right, grade 12s, thank you very much for watching. Thank you very much for joining me in this session. I hope you learned something. Don't forget, we were covering finding the equation of a circle. In the next upcoming lesson, we'll be focusing on determining the equation of a tangent and the equation of a secant, or rather a point, when you have lines on a circle. Very, very important examable session. Okay, thank you very much. Otherwise, that's all for me. Let's meet on the next session, and goodbye.